Hello, now today we are going to be looking at the intersection of two lines. Now we've done this earlier in the year in algebra, so we already know what we're about to do. If we're looking for where lines intersect, we are going to use simultaneous equations. But to put this in the context of our coordinate geometry, I have given you an example here where we have our red line and our blue line crossing on the left hand side of the screen. So we have our blue line, and its equation is given to us as x minus y is equal to 1, and the red line is given to us with an equation 3x plus 2y is equal to 8. And if we were asked, where do these two lines intersect? Intersect means where they cut each other, where they cross each other. Intersect means where they cut each other. And they cut across each other, they cross each other at this point here. Well, what's the coordinates of our point of intersection? Is going to be always start at the origin, and we go in the door 2 and up the stairs 1. So in the door 2, up the stairs 1. Our point of intersection from our graph is where our lines cross each other. That's all it means in terms of when we're looking at a picture. If we're ever asked about any form of intersection at any time, it always means where do the lines cross each other. That's all it will ever mean. So if we have a picture, we're just looking for where the lines cross each other. And in this case, it's at the point 2, 1, in the door 2, up the stairs 1. Now, we will often get these types of questions without a picture, and we'll be expected to use algebra in order to find it. And in that case, we're going to use simultaneous equations. So I'm going to write out my two equations that I'm given, and I'm going to look for their point of intersection using algebra. And again, that means I'm going to use simultaneous equations. Now, one of the ways I can know that is that I'm dealing with a situation where I have two unknowns, an x and a y. If I have two unknowns in a question, I'm almost always going to end up using simultaneous equations, particularly if I am given two equations in the question along with two unknowns. Immediately I should be thinking, could I use simultaneous equations? Now, in simultaneous equations, what we're going to try and do is add these two equations together so that one of the letters is going to add up to 0. So, in this question, I have plus 3x plus 2y in the first equation. I have plus 1x minus 1x in the second equation. If I add these two equations together right now, if I added those two equations together right now, this is a symbol I put in for saying I'm going to add them, I would end up with 4x plus 1y is equal to 9. Now that's still an equation that has two letters in it, which isn't what I want. So I'm going to need to modify these equations in some way so that when I add them together, one of my letters is going to add to 0. And the easiest letter that I can see to get to add to 0 in this question is the y, because if I multiply this second equation by 2, I'll end up with plus 2y in the top equation and minus 2y in the second equation, in the bottom equation. When I add plus 2y to minus 2y, I'll end up with 0 y's. So let's put this into practice. I'm going to multiply my second equation by 2. And you'll see why. If you're not totally happy, you'll see why in a moment. So I'm multiplying everything here by 2. So 2 by x is 2x. 2 by minus y is minus 2y. And 2 by 1 is 2, and we don't forget our equal sign. Now, this is my new bottom equation. I've multiplied the original one by 2. When I do that, if I go back to what I wanted to do originally, add my two equations together, I have 3x plus 2x is 5x, plus 2y minus 2y adds up to 0y. So I have no y's now in this new equation that I get from adding my two original equations together, and I have 8 plus 2 is going to be 10. Now what have I achieved by doing that? I have an equation that only has x's in it. and I know how to solve that type of equation. I know how to find x if I only have one unknown. So what I am aiming for in the beginning of simultaneous equations questions, and this will almost always be true, is that I am going to multiply one or the other, or sometimes both of my equations, so that I end up with the same number with a different sign in front of one of my letters. Now it can be x or y, but I'm aiming for this situation that I've got here, where I have plus 2y here and minus 2y on my bottom equation, because when I add those together I get 0y. So I'm always going to aim, regardless of what equations I'm given, I'm going to be able to multiply either of the equations or both of them by whatever numbers I like in order to get the same number with a different sign in front of one of my letters. That's always going to be the way that I'm going to approach this type of intersection question, and this is by far the most common type. So now that I've gotten to this situation, life is fairly straightforward. I have 5x is equal to 10. I want to know the value of x. So if I know 5 times x is 10, I'm going to divide both sides by 5, because 5 divided by 5 is 1, and I'll be left with 1x on the left hand side, and 10 divided by 5 is 2. So I'm happy I've got x is equal to 2. But I wanted to know x and y. I had two unknowns, so now I'm going to have to go back to one of my original equations. I'm going to take the second one, the bottom one, because it is a simpler equation, so it's nicer to sub into, and I'm going to use one of my original equations along with the fact that I now know x is equal to 2 in order to find the value of y. So I'm going to substitute in x is 2 into my equation, and now I'm going to solve for y. Now I have an equation that only has a y in it. So I have 2 minus y is equal to 1. Rearranging my equation, I subtract 2 from both sides, or I move the 2 over and it becomes minus, whichever you feel more comfortable with. I know minus y is equal to minus 1. Therefore, I can either change both signs, I should say, or, as I have talked to you about, you would say that you would multiply both sides by minus 1, and y is going to be equal to 1. That means the coordinates of my point of intersection is at x is 2, y is 1. Now lo and behold, we have gotten exactly the same answer as we did from our picture. We can see that at the point of intersection of our red line and our blue line that we talked about at the beginning is at x is 2, y is 1. And we can see when we do it out the algebraic way, when we do it out by simultaneous equations, we get x is 2, y is 1. So we are finding exactly the same thing. Obviously, if you have a picture, it's a lot faster to do it using the picture, but you can be asked to do it explicitly using algebra. So we have to be able to do simultaneous equations as well. And again, our aim is always going to be the same in these questions. We're going to start out with two equations. We're going to multiply one or both of the equations by some numbers until we get the same number with a different sign in front of one of our letters. So I could have gotten the same number in front of my x's if I started out here. 2y is equal to 8, x minus y is equal to 1. If I'd started out with this, I could have multiplied my bottom equation in this case by minus 3 if I wanted to get rid of my x's. So I'm going to show that to you very briefly. My top equation would be unchanged. My bottom equation would be minus 3x minus is plus 3y is equal to 3 by 1 is, minus 3 by 1 is minus 3. In that case, I would have ended up, when I added my equations together, I would have ended up with 0x plus 5y, and 8 minus 3 is equal to 5. Divide both sides by 5. I would have gotten y is equal to 1. I get the same answer. I still get y is equal to 1. In this case, I decided I was going to get the same number with a different sign in front of my x's. In the first way I showed you how to do this question, I got the same number with a different sign in front of my y's. You can see that either method works perfectly fine. There is no problem with eliminating your x's or eliminating your y's. You're always going to aim for getting the same number with a different sign in front of one of your letters, either x or y. And if we do that, it becomes very simple solving of equations that we can all do very confidently at this point. So that's what we need if we're ever asked about the intersection of straight lines. We can use it graphically, or we can do our simultaneous equations. And that's what we need for now.